Continue with chapter 8 solutions. Today we're going to cover the topics about solubility, factors affecting the solubility, and some other concepts related to solutions and solubility. So solubility, by definition, is the maximum amount of a solid that can be dissolved in a given amount of solvent under given condition. Majority of the solutions we discuss in this chapter will be water solutions, aqueous solutions. So if water is the solvent, then the solubility of something in water, usually the given amount means 100 grams of water. So when we present a solubility data of something in water, that data means the maximum amount of the solute that can be dissolved in 100 grams of water under certain conditions. Factors affecting solubility. First of all, temperature. Most solid becomes more soluble in water with increasing temperature. So for solid and liquid solutes, so I didn't put a liquid here, but for most of the solid and the liquid solutes, higher temperature, higher solubility. Well, remember, for solid and liquid solutes to dissolve in water, the particles have to overcome the intermolecular forces between them and goes into solution. So when you have higher temperature, those particles have higher kinetic energy that can overcome the intermolecular forces among the molecules. That's why higher temperature becomes more soluble. Here we have some data for some solids, solid solids, the solubility of them in water at different temperatures. As you can see, solubility data here means the amount of solid dissolved in 100 grams of water. So let's use sodium chloride as an example. So at 0 degrees Celsius, every 100 grams water can dissolve 35.7 grams of sodium chloride. When the temperature is at 50 degrees Celsius, solubility becomes 37, and at 100 degrees Celsius, solubility becomes 39.8 grams. Well, the temperature impact on the solubility of sodium chloride was not very significant. If you look at other data in the table, you're going to see some of them, temperature has a dramatic impact on the solubilities of them. Now, for gas solutes, if you are talking about the solubility of a gas in water, then increase temperature, decrease solubility. Okay. All right, we covered the temperature impact on the solubility. Now we look at the pressure impact. Pressure has barely any impact on the solubility of solids or liquids in water. However, pressure does have a major impact on the solubility of gases in water. The solubility of gases in water follows Henry's law. Henry's law states that the amount of a gas that will be dissolved in a liquid, most likely water, at a given temperature is directly proportional to the partial pressure of the gas above the liquid. So, the higher the pressure of a gas above the liquid, the more it will dissolve in the liquid. And this is how those carbonated drinks are made. So many carbon dioxide was pressured into the water. So at a higher pressure, they apply high carbon dioxide pressure above the liquid, higher pressure, higher solubility. So a lot of carbon dioxide gas is dissolved in water under high pressure. Once you open the lid, pressure is released, then carbon dioxide comes out from the water solution, and that's why you see bubbles when you open the lid of the carbonated drinks. So as the pressure of a gas above the liquid increases, the solubility of the gas increases. That's it. Now, some more concepts related to solubility and solutions. Saturated solution, a solution that contains the maximum amount of solute that can be dissolved under a given condition. This picture here shows us a saturated system. You have some undissolved solute in the system. Solution is saturated. If that's the case, sitting here watching this flask forever, the amount of undissolved solid will never change. However, even if you do not observe any change, there are two processes going on all the time. There are particles on the surface of the solid getting dissolved. There are also particles in the solution deposit back to the surface of the solid. The two opposite processes are happening at an equal rate. What do we call this? Equilibrium. So when a solution is saturated, and if you still see some undissolved solid in the system, you know there is an equilibrium going on. Dissolving and depositing never stops. They are happening at an equal rate. Interestingly, we have a supersaturated solution. Although it is not seen very often, but it does happen. So what happens is that sometimes a solution can contain more than the maximum amount it can dissolve. But this kind of solution is unstable. Okay? It temporarily contains more dissolved solid than that present in a saturated solution. This kind of system is not stable. Once it is disturbed, sometimes if you shake the solution or if you scratch the surface of the container inside of the solution, the crystals, the extra amount of the solid dissolved, will come out in a dramatic manner. You see tons of crystals coming out rapidly. All right. So anyway, a solution sometimes could be supersaturated. Unsaturated solution, this is easier to understand. A solution that contains less than the maximum amount of solid that can be dissolved. Most solutions we encounter fall into this category. Concentrated and dilute solutions. Concentrated solution is a solution that contains a large amount of solute relative to the amount that could be dissolved. Okay? And dilute solution is a solution that contains a small amount of solid relative to the amount that could be dissolved. A picture showing you a concentrated and dilute solution. On the right is a dilute solution. If you evaporate a lot of solvent, then the solution becomes concentrated. Well, again, concentrated, dilute, these are two relative concepts. That's it for today. See you next time.